That looks like we got sound now. Let's wait for confirmation online. Yep, there we got sound. Very nice. Alright, so welcome to my stream. This is CodeWorkShop. We haven't had a video or something like this in last activity has been on February 2018. So about 2.5 years ago I had my last activity. Well, not really. My last live stream was in April 2017. So yeah, well, it's been a while, but I think I'm back. I hope so. And maybe you've seen the title of the live stream. It's called Building a Web Countdown with a 7-segment display style in p5.js. If you don't know p5.js, let me bring it up over here. Let's do this. And we should still have audio. Looks great. So p5.js, JavaScript library for creative coding. Blah blah blah. So essentially, it's a JavaScript library for creating graphics easily. And you have this canvas, which is currently initialized with a 400 by 400 pixel size. And you got, like in Arduino coding, a setup function and a loop function, which is called draw here. And in this setup function you do things once, and in draw you do it in a loop forever until the program is ended, aborted, cancelled, whatever. And if we start this example here, we see on the right side on our preview window we got a canvas with a 400 by 400 square, and on this is on which a background with the gray color 220 is drawn. Like the normal HTML colors, there is black and 255 is white. So 220 is a light gray, obviously. So my idea was to check out how to use p5.js with npm and Node. Complete library, get started. We don't want to use the web editor. I would like to on your own computer. There it is. Downloading a copy of the p5.js library. You could use a content delivery network. A simple page might look like this. Very nice. Alright, so I'll be switching over to here for a second so that I can set up over here. I need to clean up my editor. Remove. so that we can start very quickly. Close all tabs, don't save this. New folder. Let's go into this code workshop. Segment display. All right, switch over to here. And now we are in the Atom editor, and I will create a index.html into which I'll be copying this HTML and inside the folder I just created I will now HTTP server. Yes. Localhost. Yep. Here we are. But I ain't have NodeMon up. So how did you use NodeMon? I can't remember documentation. Let's find out together. Usage. NodeMon, your Node app. NodeMon HTTP server. Anyway. Oh. Such a genius. We don't need NodeMon, because as soon as we change anything on here, the server automatically delivers the new file. So no need for that. We need a new file. Call it sketch.js. And okay. Let's copy this quickly. And if we now can close those and those and reload, and we should see some stuff happening. Very nice. Whee! Choo 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 choo. All right. So the idea of this stream is that I kind of force me to program some stuff, and those live streams will be taken down at some point after which I have cut out some kind of tutorials which I will then publish on this channel, and then we have a polished version of what I do in those streams, and all those thinking pauses will be gone, and we're already, looks like, streaming 14 minutes or over 15 minutes, and we haven't done anything. So yeah, look at me, I'm totally a perfect streamer. But hey, it's my first stream since 3 years, and I will try my very best. And now I'll be starting a stream, a new tutorial for the 7-segment display styled web countdown written in p5.js. Let's see what we can do. Maybe we start. Oh no, that wasn't what I meant. Let's go here, let's go here. I think I will start here. Wow. Alright. I don't have an introduction. I don't have a greeting. I don't have anything. But I will try. And maybe I will try a few times. But looks like we don't have too much viewers currently online on the stream, so I don't care. Hey there, CodeWorkShop here. Hey there, welcome to the CodeWorkShop. Today we will build a web countdown in a 7-segment display style with p5.js. Alright, that sounds great. I now should remember the whole thing and talk a bit faster. Okay. Hey there, this is CodeWorkShop. No. Hey there, welcome to the CodeWorkShop. Hey there, welcome to the CodeWorkShop. Today we will build a web countdown in a 7-segment display style with the p5.js library. Let's do this again. Hey there, welcome to the CodeWorkShop. Today we will build a web countdown. Hey there, welcome to the CodeWorkShop. Today we will build a web countdown with a 7-segment display style with the p5.js library. Let's get started. So I have initialized the project with a simple HTML file including the p5.js library from the content delivery network from JS Deliver, and we got a sketch.js opened over here. So what is p5.js? p5.js is a simple graphics and drawing library, and if we go into the code, we got two main functions. We got the function setup and we got the function draw. The setup function is a function called once when the program gets called, when it's started, and the function draw right there is called in an endless loop over and over, and we do whatever put is in there. The setup gives us right here a canvas, create canvas by the size of 400 by 400 pixels, and if we look here, we got a about 400 and 400 pixel big square over here. And if we go into the code again, we got a draw function, and we ignore that. Well, yeah. So we got some functions like fill and eclipse, which draws an eclipse with at an location of the mouse, and a size. This is a default example I got of p5.js, p5.js.js. No, there it is, p5.js.org. If you want to learn more about p5.js, stick around and watch the tutorial, or go to p5.js and look at the get started tutorials section. There's also a p5.js online editor, which has the same functionality as my code over here, but it's an editor I'm more familiar with and I like more than this over here. But if you're on the go and have an idea or too much spare time, or your lecture is just boring, just get to editor.p5js.org and play around a bit. Also, we got the reference here, and here are all the functions we can use. There are a lot. p5.js is pretty powerful. We also got, if we scroll down again, 3D support for setting moving cameras in 3D space and placing objects in 3D space, and accessing DOM objects, rendering, and everything. We will come to this reference a lot of times later, but now we will start with our 7-segment display, for which I will check the line, which is also just thinking about. I once had a 7-segment display like thingy made, but I'm currently well, whatever. Let's start with a simple line. We got the syntax x1 x1 y1, which are the x coordinate and y coordinate of the first point, and the second coordinates are for the second point, obviously. And also we got 3D support right here for using the z-axis too. So let's take this and simply draw a line from 50 to 150. And let's also say stroke 0, let's say 5, and fill 0. There it is. So right now we should There we go, very nice. Okay, now we got a simple line. We set stroke, which is the width of the line. Set it to 5 pixel, and filled is the color in which the line will be drawn, and I set it to 5, but we can also say 0 to 55 0 for this page again. Give me a second. Sketch, yeah. Okay, give me a second. Well, alright, so we go into the draw function and write the following code. A simple stroke and line. The line should go from pixel x 50 to a 100, and in the y coordinate it should stay at 50 pixels. And we're saying stroke 0 to 55 0, which is the RGB value, like normal HTML color codes. 0 red, 255 green, and 0 blue, so it should be a green. And if we check, we got a green line over there. Let's make the line a bit thicker, which we can do with reference. Stroke rate. So now we want to make the stroke a bit thicker, so we see more, and we can use the function stroke weight and just say 5. Let's see where we go. We go nothing, nowhere. Let's say 50, which is a lot. We go nowhere. We reload the page, and we get 50 very well. Okay, 5 is enough. Let's start creating a 7-segment display. So I will take a sheet of paper, I think, or do I? Or we take paint, yeah. So typical 7-segment display looks like this. We got our 7 segments, and however we light them up, we can create the number 1, we can create the number 2. We can create the number 3 and so on. So we, most of the time, we also got, right there, we got a dot or a double dot, I don't know. Most of the time we have a dot right there, and now we have 8 lights that can be on or off. So if we check Wikipedia for the 7-segment display, we see that there are a lot of 128 different states we can reach. And we got the hexadecimal values which we can use. And I'm looking for there it is. So we can segment the display into 8 different on or off states, binary states, and 8 binary states are pretty close to a byte, so we can express every state of the 7-segment display with 1 byte. And there is a standard. There is a standard for talking to a 7-segment display by calling the elements by A, B, C, D, E, F, G and the decimal point, or you can, this is the first byte, the second, not byte, bit. So this is the first bit, second bit, third, fourth, fifth, sixth and seventh. I missed one there. We should be by the 8th right here. And you can either describe a byte by starting at A, like this, the first, second, third, fourth, and so on. Or you can go in reverse and say this the first, second, third, and so on. And that way you get hexadecimal representations for ease of use, which we will now try to implement. And first of all, we create a function, draw segment, I think, segment. We give it an X and Y and a value. So now we should think about placing the lines. So this right here should be our XY coordinate. We give the function to draw our segment display, and from there we would like to draw, I think, in the ABC, A, B, C, D, E, F. Horrible painting on paint, but what do you expect? And DP, which we will add as an extra. So we would like to start with the A. which we want to draw. Let me think. Let's say this is 5 pixels. You would like a spacing of 10 pixels around there, so we would like to start a line at x plus 10, at y to x plus, let's say 60, so plus 10 plus 50 to y. This should be our A. Let's go to B. B should be so this is 10, this is 50, this is 10 again, so we should start at x plus 70. We should start at y plus 10. We should end at x plus 70 because we want to go straight down, and end at y plus 60. Next up is C. C is 10, 50, 10, 10. So 80 pixels down. 80 pixels down and 70 pixels to the right. We would like to reach x right there, and 80 plus 50 makes 130. So now we should have a few lines drawn, and as we see nothing because we haven't called the draw segment function, which we call with the euro at a semicolon, and there we have our beginning of our 7-segment display. Let's keep doing this for the next D, E, F, G. So D should be simply a but drop down by 10, 20, 40, 10, 20, 30, 40, 140. To 140, just like this. E should be like C, part, just like this, but at x plus 0. F should be like B, like there, but without any additives to 0. And G should be like A, but drop down by 70, plus 70, plus 70. Alright, so now we should have a 8-segment display, which we don't have because we messed up one line. It looks like this one. Okay, this fix looks almost like it. And this should be 60. So now we should have our display. So now that we have all our lines arranged and drawn the typical 7-segment display style, we will push them away a bit so we can see the full extent, because they were half clipping away into the void. So now we can remove this and add a decimal point with an ellipse at x plus 70, y plus 140, and a size of 10, I think. Let's see what this looks like. It's a bit too big. Let's change those values to 5. And now that looks a bit better, but I think we should put it way further right. That looks good enough. So now we need to add some logic and use the value property, which should be a binary value. 1, 2, 3, 4, 5, 6, 7, 8. So we get a value between 0 and 128, a 7-bit value, which contains, which can be converted to 7 bits in this style, and we say the furthest right one is our A, the next one is our B, the third one is C, and so on. And if it's a 0, we will draw this line in gray, like the display's off. And if it's a 1, we will draw it in green, like we are already doing. And also the dp, the decimal point, will be only drawn if dp is 1. So we can add it right here if dp is 1. Let's define color on is, do we have RGB properties? p5 color, that looks great. Let's check the source code. We got wall values. this out. So either we get an error or everything is great. We got an error. Need colors. So we have values. This might be an array. So let's add those brackets. p5.js color. We can do just like this. I think let color equals p5.color, like this. Hmm. Can we use this as a tuple? Let's see. Well, no. Sad. But how do we store colors as a p5.js color variable? Color variables, yeah. Okay, we only can use the. Okay, let color on equal color null 255 and null. And now it should work. There's an error due to color on not being defined in the current scope. Oh, come on. Oh, I see. I think I see. Like this. Yeah. So now we want to use some variables to store our colors so we can change them later. We have the color function of p5.js to create a new color, which we can store in a variable. But we can only use color in the scope of the p5.js stuff. But we can only use the color function in the scope of p5.js, which is only inside of setup and draw segment and so on, and not up here. So we need to define the variable color inside of setup, or we could use or we could initialize color on in draw segment or in draw, but not up here. And we need to do it this way, because if we would define the color on inside of setup, we wouldn't be able to access it from draw, because it's only in the scope of setup available and not in the draw scope. So we define color on globally, so every function can access it. And we also create the color off, which is I think 20. So now we say if decimal point equals 1, we say stroke color on, and else we say stroke is color off. And we should not need those brackets. And now we should be able to see our decimal point being in the color of color, because we say the decimal point is a 0. So if we reload, we see it's a black dot, which I would like to have more bumping, or it's a grayscale value, so we can simply use one value, and I will try maybe 200. It should be a brighter gray. Yeah, that looks better to me. So next up, we would like to use those values to do something useful with them. For example, turn off lights however we want. So we can use bitwise operators. Let's check the documentation, what they say about those. Do we even have them in this? JavaScript bitwise operators. So we would like to use right shift, and we want to use the AND operator, I think. So we want, first of all, check the last bit right here, and we will do this by simply creating a mask and using a AND operator. This will add those bitwise, those bits bit by bit together. So we will see, let's see, the AND operation makes a 0 and 0 to a 0, and a 1 and 0 will be also a 0 because we need both sides or both operands to be a 0. So a1 and 1 equals a1. So if we say use this mask right here to compare, I'll make the AND operation. We will ignore the first, all the first bits up here, because we will use the AND operator and we will always get a 0 because we got a 0 down here. And right here we have a 1. So whenever up here is a 1, we get a 1 as an output. And if there's an if there's a 0, we will have 1 and 0, and this equals a 0. Interesting noises. Let's put my headphones away. Okay. So let's implement this. If value and 1, because this has a numerical value of 1, and now we give a second. And now if we combine the value and this 1, and we get an 1 out because there is a 1, and this entire thing will be a 1, and our if will see if 1, and we'll do whatever we write here, which should be our stroke color on, and else we will have our stroke color off. We can write this in a shorter form by removing this if, adding a question mark, and then using the short syntax like this. So we will say value and 1. If this is true, the question mark, if it's true, then we will do this, else we will do the color off. We need a stroke right there. So this should be our A. Let's put a on for testing there. And now we should only check the first bit on the right side. So if we write a 0 right here, because that is our value, this is a 0, we should have our A segment off. And if we write a 1 right here, it should be on. So let's turn it off. And we see it's off up here. And if we turn it on, we should see that it is on. So now we will repeat this thing over and over. But before we do this, we want value to be value right shifted, or is it on the left? Give me a second. Alright, yeah. One's on the right, okay. So now we shift our value to the right. So we take everything we have up here, let's say This is A1, which should turn our B segment on. And with this operator, we add a 0 at the beginning and remove the last bit. And now we have shifted the whole thing by 1 bit to the right. And we now see that our bit for the B, which was previously at the second position from the right, is now at the first position from the right, which we then will be able to check for our B. And after that, we will then shift the whole thing to the right again, and so on and so on. Oops. And this doesn't look right. Unexpected semicolon. Oh, do we really need a 1 right there? This looks better. Alright. So we have to use a 1 at the right of those shifting operators. But now we can copy and paste the rest here. Just like this. Well, we don't need this down there. So now only the first up there should be on, and if we go back to the Wikipedia page, we see that, so we are now using the GFE DCBA scheme, because we are looking at the right first, which should be our A. And now if we take a 0x4f hex value and put it in here, we should automatically have our 3 right here, and we have a 3 right here. So now we can draw a few more. We will place them every 150 pixels, and for simplicity let's use a simple for loop which starts at 10, goes to 6 times 150, and let's simply say to 6 and I++. Draw a segment at x, at 10 plus I times 150, which is the width of our displays. And this way we should then draw 6 of them. Remove this, because we got a nice loop. Save it. And we got 3. Oh, we have a problem with our canvas, because we only said it should be 400 by 400, which is too small for our 6 displays. So let's say 7 times 150. And now we have 6 7 segment displays, all displaying a 3 because we told them so to do. Great, let's do let values equal an array. So I just realized it would be cooler if we'd use a integer array called values, and to which we simply write our values which we use. And now we can simply use a for each loop for each value in values. We say draw segment with the value, giving a second JS for each. Very well. So we will use a for each loop, which gives us a value and a index, which we will both need. And we use an arrow function to nest it in. And now we can remove this for loop, put the draw segment in here, and now our I is the index from the for each we get, and we replace our value right there, and we should have 1, 2, 3, 4, 5 times a 3 right here, and we get nothing. Line 16. Oh, values. And there we are. So let me put this over here. First one, let's say 3F. Next one, 06. 5B. 4F, which I just removed, and 66 and x60. Save this and reload, and now we got a 0, 1, 2, 3, 4, 5, which is pretty hard to read, so let's set background to 0. Pretty hard to read still. 50 maybe? A good 50. Better. Let's simply say stroke weight to 7. Better, but still not perfect. I think the spacing is not perfect. Let's do this. Alright. Think we could tweak the on color a bit. Let's quickly use off screen the color picker. Okay. The on color I will reduce to 128, and now we should have a pretty dark green. Yeah. 180. Better. Let's decrease the off color. Let's increase the on color. And I kinda like this. So let's keep it this way. Alright, I think I will make a stop right here. Let's switch to here. Hello there. How's it going? I will end the stream right here because I'm getting tired. Just watching my stream in the smaller window. Looks like I'm almost a funny guy. Alright, so I will end the stream right here. First stream in a while, over an hour and 12 minutes. I'm quite pleased with that. My English can improve a lot, I think. I think anybody who might have anybody who's run into the stream might have left immediately because of my super duper perfectly spoken and accent free English. But what can I do? Could learn better English. Well, anyway, before I keep on talking shit, I will say goodbye. Wish you a good night, if it's evening or a night wherever you are. Maybe it's a good morning, maybe it's a good good day. Have a nice lunch, maybe. Whatever. I will leave you right here. I will switch to the pause screen because I don't have a ending screen right now. So anyway, I thank you very much for listening to my beloved voice. I hope you enjoyed. And I will see you maybe tomorrow evening at the same time, about 8 or 9 p.m. Central European time, I think. I think so. Yeah, okay. So, thank you very much for watching. Thank you very much for listening. Thank you very much for participating, not in the chat. It was a pleasure for me being live for absolutely no one. And I will see you later, tomorrow.